And we're back with part 2 of CPCTC, or as I like to call it, CPOCTAC, triangle congruence. This is Mr. West, and this is another Kuta worksheet tutorial. We're doing proofs here today with this part 2. I suggest watching the part 1. It really kind of goes step by step, slows it down, breaks it down into easier components. We're going to be going a little bit faster with part 3, or question 3 through question 6 in this video. So let's get started. We're given VB bisects angle EVO and EBO. So the first thing I want to do is I want to highlight this bisector. Okay, so we got that bisector, which bisects this angle and this angle. So what does that mean if it bisects it? Well, I'm going to go ahead and draw this on my diagram just so I remember. I know that these angles are going to be equal if it's bisected, and these angles are going to be equal if it's bisected. Okay, so I got that set, and I'm asked to prove, I think, that these angles, whoops, I guess I can use that color, that these angles are congruent. So I want to know about this one and this one. So how do we do that? Well, first, this whole process is proving the triangle's congruent first. That means this blue triangle, okay, I'm going to color it all the way in. This blue triangle and this purple triangle have to be proven that they're congruent in every way first, and then we know that not only are the segments that we prove, for example, it looks like here we're going to prove ASA, that those are congruent, but all the sides and all the angles are also congruent. Okay, so let's go ahead and start. We have VB bisects EVO. This is given. Okay, it was given in the first stipulations of the problem right here. Given. Definition of angle bisector. Now, what are we going to do with this? Like, how do we know what bisected angles do we put? How is the sequence even set up? Well, first, this particular proof is going off of this. So this one, this given leads to the step 2. So if VB bisects EVO, we're going to look at EVO and we're going to see, okay, what happened with EVO? What givens, what new measurements did it tell us? Well, it told us that this angle, EVB, okay, that's EVB, angle EVB, is congruent to, let's make it, what color? Green? Green, I suppose. It's congruent to this one. Angle OVB. Okay, so those two angles which we marked in orange are here and here. So we know that those are bisected by segment BV, or VB as it calls it, ray VB. And the reason why I'm choosing these two over here and not these two is because in the previous step it says angle EVO. That's this angle, whoops, that's this big angle right here. So obviously it's asking for those bisected ones. Okay, so now we're going to say, what did I write? Angle EVB is congruent to, I'm just going to leave it in gold if you don't mind, OVB. And that definition of angle bisector. Now we're moving on to the second given, which is VB, and actually I should change it to BV. I guess we'll just try to keep it consistent. I would be super mad about you saying it's a line. Is that a line segment? Oh, it's a line segment. So I'm just going to keep it VB. My mistake. VB bisects, and now we're going to the other angle, other side. EBO. Oh, it gave us angle. So we could have called this, I didn't even realize this. We could have called this angle 3 is congruent to angle 4. Now, I forgot something important, and that's is any time I write the congruent symbol, I should write a letter along with it. In this case, I'm going to write the letter A because I wrote that two angles are congruent to each other. Okay, so I wrote an A. Then we have, look here in this fourth step, after we said, listen to the next given, is these two angles are congruent. That's another A because they're two angles. And then I'm going to give the same reason. That's the definition of angle bisector. All right, now I have BV congruent to BV. This one we have a lot of practice doing. Okay, this is the reflexive property. technically of congruence. Okay, and guess what? I have another congruent symbol. And what does that mean? It's going to be an A or an S. In this case, it's an S because we have this segment on top. So now we just have to analyze, looking at the diagram. Okay, what do we got? We have an angle, a side, and an angle. ASA. And that's why it says ASA here. So we're going to say the two triangles are congruent. Triangle, we'll call it BOV, is congruent to triangle BEV. Bev and Bob, congruent to each other. Now, this step, this always precedes CPOCTAC. I don't like CPCTC, whatever. It's easier to say CPOCTAC for me. This always precedes. You have to have the triangles congruent first before moving on. I'm going to highlight this just because it's so important. So many times I see people say, oh, the triangles are congruent because of CPOCTAC. No, the triangles aren't congruent because of CPOCTAC. You're always going to use 3 letters to prove triangles congruent. So now that we have angle E congruent to angle O, why? Well, because we already proved that the triangles were congruent. Take a look. Previous step, number 6. We already proved that they're congruent. So we know that we can say, well, corresponding parts of congruent triangles are congruent. If they're congruent, then everything about them, all the sides, all the angles, etc. For example, we could have said BO is congruent to BE. Why? Because it's CPOCTAC, because corresponding parts of congruent triangles are congruent. We could have said EV is congruent to OV. Why? Because everything about these triangles is congruent, so we can say everything is congruent, angles and sides. Let's move on to number 4. We have here, this is given. I'm going to try to speed this up a little bit just so you guys can see more problems. Okay, we need another given, so we're going to say angle JKL, congruent to Martin Luther King. Given. Then we have KL, congruent to KL. That's always going to be reflexive property. Okay, but let's back up a second. I forgot to do something again. Guess what I forgot? To list out what I have. I have this one, I got this one, and I got this one. This one was a side because the line segment's on top. This one's an angle because it's got the angle right here. And this one is another side. So we're probably going to have SAS. Let's take a look. Let's draw it on the diagram just so we know. JKL is this angle. And then MLK is this angle. So we got that one drawn. Then we have JK is congruent to ML. JK congruent to ML. And then we have KL congruent to KL. So we got KL congruent to KL. All right, now, this is confusing when you have overlapping triangles, so I'm going to redraw these triangles, one in blue. So you got this guy, and then I'm going to draw another one in purple. Okay, and let's just pretend they're congruent. I know I didn't draw them perfectly. Okay, now I'm going to transfer over my lines that I've already drawn. Okay, so I got that angle, I got that side, and then I got this side. Always separate the triangles if you can. So you can kind of see how I had these triangles drawn here. Okay, I got this one drawn. I got this one drawn. Okay, kind of a sloppy there. Maybe you can just refer to it. So that's what it looks like. I'm going to draw it again just in case this helps you. Okay, so we had this one. I'm just going to draw a little bit nicer. Look at that. I'm an artist. So then we have those two. Now, what do we have for both these triangles in terms of congruence? We have A, nope, that's not an A, sorry. S, A, S, S, A, S. It's the same on both, so we write S, A, S. Now, we're asked to prove JL is congruent to MK. So that's what we're going to write for our last step. JL congruent to MK. So now we know that corresponding parts are congruent triangles. Because these are congruent, everything about these guys is also congruent. So we're just going to write CPOCTAC for that, and we're good to go, okay? So the trick to this problem, in my opinion, is separating the triangles and then going from there. All right, here we have this problem. We're going to start with our givens. We have RT congruent to RV. We're going to have, okay, trying to look here, Mango. Okay, So we have measure of angle TRS is congruent to measure of angle, well, it's not congruent, it's equal to VRS. This is kind of a nitpicky thing. I'm not a super big fan of it, okay? But notice how there isn't a congruent sign in this step, okay? There's no congruent sign, but there is a congruent sign here. So this one is a segment, so we're going to write S, but since there's no congruent sign, we can't write it yet. Now, look at the next step. There's a congruent sign, so we're going to say, okay, look, we got an angle now. Now, what's the reason why? Wasn't it already listed as given? Well, the reason is kind of a dumb one, in my opinion. It's angles with equal measures are congruent, which I think is kind of dumb. I mean, it's pretty obvious that if they have the same measure, they're also going to be congruent, but you technically need to list that step. For my class, you don't really have to worry about that too much. So let's move on to the next one. Here we have RS congruent to RS. You guys should be great at this one. This is reflexive property. Because it's a part of both two different triangles, we have to prove that it's equal in both triangles. Okay, and if you want to see the two triangles, I always recommend highlighting them. We got the blue and the purple. And if you want to use a different color, that's incorrect. You must use blue and purple. Now, we have three measurements here, so guess what that means? That means we should probably have enough information to prove these triangles congruent. So we have RT congruent to RV, we have TRS, that's this one, and then VRS, that's this one, okay? And then we have this reflexive side here. So guess what? That is side, angle, side, side, angle, side. That's for both of them. So we're going to say triangle TRS congruent to triangle VRS, and that's side, angle, side. And then we can say these are congruent, CPOCTAC. Everything about this triangle is congruent. So I'm going to show that in orange. This angle is congruent to this angle. RS, RST on RSV. Okay. And then here's the one we're trying to prove. This one and this one are congruent, but also this side and this side are congruent. So everything about these triangles is congruent, so we can use CPOCTAC for anything. Oh, I'm going to scroll down to the answer key. Last one. AD is an angle bisector of BAC. So AD, that's this guy. Angle bisector, yuck. Terrible line. Angle bisector. So that means we can go ahead and write 1 is congruent to 2. That's good. But that's something we're going to be proven. That's not a given. AB congruent to AC. AB congruent to AC. AB congruent to AC. This is what I normally like to do, is just draw as I talk it out, okay? So let's see. We're going to list our given first. So sorry, AD is, that's Anthony Davis, is angle bisector before and after care. And that is given. Okay, now, definition of angle bisector. What did we bisect? We said angle 1 is congruent to angle 2. Alarm, 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 congruent. Guess what we got? An angle. Finally got it this time. What do you know? We have another given. That was my friend AB. What is it? AB congruent to AC. Alarm, alarm, got it. Okay, turned off the alarm, snooze. Okay, that was a segment or a side. Now reflexive, what are we going to do for reflexive? Guess what? That was the first thing we highlighted. AD is congruent to AD. Alarm, alarm, got it this time, pretty quick. That's another side. Okay, now just because this says ASS, don't you dare write that word. Okay, we don't want to be swearing up in here. Don't show your mom this if you're going to write that. Okay, but we got to look at the diagram and say, okay, we got a side, we got an angle, and then a side. Side, angle, side for both. So that's SAS. Something I get too much of in class. So then we have BD congruent to DC. Why? Okay, this was our proof. This is what we wanted to prove from the beginning. Because the CPOCTAC, because these two triangles are congruent, everything about them is congruent. So there you have it. That's all we got for today. Hope you enjoyed it. Hope you learned something about proofs, and I look forward to seeing you next time on West Explains Best.